the slope-intercept form, which we had last chapter and we've had a few different times, and we actually even had in our graphs yesterday. Remember when we were trying to graph those lines? So we have y equals mx plus b, where m is the slope and b is the y-intercept, or the place where it crosses the y-axis, just in case you're not remembering what the y-intercept means. So where we're crossing the y-axis, and then the slope, the rise over the run of our line. Remember too, if there's a top number and not a bottom number, the bottom number is always understood to be what? Who knows? 1. Thank you. And then also in the last chapter we had the point slope form. So if we didn't know the y-intercept but we knew one of the points, we could also put that in a graph. So the point slope form, started with y, and then we had one of our parts of our point, the y part, and then the slope, and then x, and then the x part of that point. So if you were given a slope of 4 and a point of 2, 6, that looks like, you could put that into an equation. And that equation would look something like, let's see if we can put it out here quick for you. If we were given that point and that slope, we would just have y equals the y part of that, which was 6, plus the slope, which we said was 4, times x minus 2. And you could leave it just like that because that's point slope form. Or you could go ahead and put it in slope-intercept form if you wanted to. You don't always have to, by just distributing the 4 and then combining your like terms. So if you wanted to do that, we'd end up with 6 plus 4x minus 8. We'd subtract the 6 and the 8 together, put these together, to get y equals 4x minus 2, because 6 minus 8 is negative 2. Either way is fine. You can put it in your calculator this way and graph it. You can put it in your calculator that way and graph it. So each are acceptable reasons. Back in geometry, you did some translations where you moved graphs horizontally or vertically or both. So a translation is just a movement of your graph. So if we took a line, so we had some function y equals f of x minus h plus k. Generally, y equals f of x. That's what we had in the notes yesterday, guys. So if we put some letter in here and we make it negative, that's going to give us a horizontal shift. Any number on the outside is going to give us a vertical shift. So we're going to look at a couple of those and why it's left positive and right negative. But if you start with the base function, so grab your calculators out for a second. That's easiest to do if you have your calculator. And I'm going to slide this up just a little bit for us here. We're going to start with the base function, f of x or y equals 2x. And if you could zoom 6 to graph that so it'd be in standard form, standard graph, so that would be good. Then I want you to just look at a vertical shift or shift up. Leave that one on the graph, the 2x, and now add 2x plus 4. So we're going to shift it vertically up 4. So when you graph it, this time you have your original one, plus you have the line that's up 4. Now, it is kind of deceiving. So what I always recommend that you do is find one point on this graph, and you're going to do something like this today. Find a point on your original graph, and then see where that point corresponds to on your new graph. So this particular point from the old one to the new one is up 4. So the easiest thing to do, find a point and then its corresponding point on the new graph.
Uh-oh.
It'll come off. Maybe, eventually.
Uh-oh.
There you go. See? Little spit. Saves it all. Okay. I know, right? Hello, Alex. You're returned. You do? Did you have it first black?
Yeah.
Was there a calculator? Where do you set usually? Right here? Shaylee, did you have a calculator when you got here by chance? We'll look for you though. Okay?
Thank you.
Alright. Instead, if I wanted to move it right 3, I'm going to add a number inside the parentheses here. So go ahead and instead of your second one, leave your first one there. This time put 2 and then we're going to parentheses x minus 3. And now you can go ahead and graph that guy. And we have our original. And then we should have one that moves right 3. This time I use pencil. Look how smart I got. So we go from that point, and now in the new graph, it's over 1, 2, 3, till I get to my new point. So we shifted 3 to the right. This guy is negative because the original formula, way back up here, was x minus the horizontal shift. So anytime that it's negative here, you're going to be shifting to the right. Anytime that it's positive here, that really meant that you were going negative, negative, so it switches the sign. So you'd be shifting to the right, or the left, excuse me, when it's positive, and the right when it's negative. And so in the last example here, we're going to do both. We're going to go ahead and shift to the right 3 and up 4. So if you take your same set of equations, get rid of the second one again. And you can just say it's 2 times x minus 3 plus 4. Our new line, oh, I put on a separate line, didn't I? Our new line is over and up. So it's over 3 and up 4. The inside of the parentheses moving into the left and the right. The outside of the parentheses moving up and down. Questions about that? All right, you can stop that for a second.